Welcome to a video on Pre-Calculus 5.3 looking at the sum and difference identities. So this video is not going to cover where the sum and difference identities come from. That's going to be presented in a different video. So let's go over what the sum and difference identities are. So let's start with the sign. So we have the sine of u plus or minus v is equal to the sine of u times the cosine of v plus or minus the cosine of u times the sine of v. So let's break this down. Let's first talk about the plus and the minus here. So if we're using a plus, this symbol right here would be a plus. If we're using a minus, then this symbol right here would be a minus. Now let's look at the u's and the v's that we're talking about. So u is whatever the first thing is in the sum in the parentheses, and it's going to go here and here. And v is the second, and it's going to go here and here. Now let's take a look at the cosine version of it. So the cosine version is going to be cosine of u times the cosine of v minus plus, and we'll talk about what that means, times the sine of u times the sine of v. Okay, so the minus plus is telling me that if it's a plus, we're going to use a minus. And if it's a minus, we're going to use a plus. And so these signs are alternating, okay? And then of course we've got u and v. So u is first, so u is the first one in each pair, I guess, and v is the second. Okay, there's a little song to help us remember the order of all this, okay? It goes sine, cosine, cosine, sine, cosine, cosine, sine, sine. Okay, it's just a little, I don't know, it's not really a song so much as it is a way of remembering the order. Maybe just, let's sing it again. Sine, cosine, cosine, sine, cosine, cosine, sine, 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 cosine, cosine, sine, cosine, cosine, sine, sine. Oh yeah. Okay. You have to remember the plus or minus stuff and all that. Okay, so let's actually practice using it. Okay, evaluate each without a calculator. We have the sine of 105 degrees. Okay, well, if we can't use a calculator, we can use a unit circle, but 105 degrees is not on the unit circle. But 60 and 45 are, and 60 plus 45 is equal to 105. And so that's how we're going to use this formula to get our answer without using a calculator. Okay, so we're going to use the sine formula, and we have our u is 60 and our v is the 45. Okay, so using the formula, it's going to be the sine of 60 times the cosine of 45. All right, and our symbol here is a plus, so that's what we're going to use here. We're going to use a plus, and then we're going to do the cosine of 60 times the sine of 45. All of these values we can look up on the unit circle. Okay, so you can go back and look at your unit circle. We can figure out what each of these are. So we get that the sine of 60 is rad 3 over 2. The cosine of 45 is rad 2 over 2. Plus the cosine of 60 is 1/2 times the sine of 45, which is rad 2 over 2. Okay, cleaning this up, these can multiply and these can multiply. That gives us the square root of 6 over 4 plus the square root of 2 over 4. And then we could just put that over 1 big 4 because it's the common denominator. Okay, and there's an answer. All right, let's try cosine of 15. So can you think of a way that we can write 15 using things that we know, like 30, 60, 45? Not by addition, but perhaps by subtraction. So there's actually two ways to do this one. You can think of this as the cosine of 45 degrees minus 30 degrees. Or you could do the cosine of 60 degrees minus 45 degrees. Either one will work. Okay? All right, but I'm going to just use the bottom one. So we're using the cosine formula, and this time we're using subtraction. So if we're going to be using subtraction here, we're going to use addition in the other part, or we're going to add. Okay? So we're going to do, let's see, our u is 60. So just like before, we put it first in each pair, and then the 45 goes here. Okay? So we're going to have the cosine of 60 times the cosine of 45 plus, remember, we're using the opposite. If we're doing subtraction, we're going to be adding. If we're doing adding, we're going to be doing subtraction. It's always opposite here. And then the sine of 60 times the sine of 45. All right. So then we just got to go back to our unit circle and figure out what these things are. We already got the cosine of 60. It was 1/2. Okay. We already did the cosine of 45. It's rad 2 over 2. Sine of 60 was, it's the same things that we just used from before. And then the sine of 45 was rad 2 over 2. So interestingly enough, I don't know if you realize this, we are going to get the exact same answer. Because pretty much everything that we had over here is just over here, and everything that we had over here is over here, and it's just the same answer. Curious. Okay. All right. Let's continue with some more examples. We're going to write the following as a single trig function. And so you can hopefully recognize that this looks like what these formulas are, but we need to go backwards. Instead of going this way, we're going to go the opposite way. We're going to go this way. Okay, so let's look at the pattern that we have here. We have a sine, a cosine, a cosine, a sine. So that fits the pattern of a sine, sum or difference. Okay, it is adding, so it is a sum because in the sine formula it's going to be the same. So this is going to be the sine of 22 plus 13, which is the sine of 35. And they didn't ask us to find what it is, they just wanted you to find the, they wanted you to find it as a single trig function. Okay, so then the next one, we're not in degrees, we're in radians. We have cosine, cosine, sine, sine, which is cosine. You should also notice that it's adding. So if it is adding, we are actually going to be subtracting. Okay, so it's cosine of pi over 3 minus pi over 4. So we're going to need to do a little common denominator fraction work to get pi over 3 and minus pi over 4 into one thing. So let's just get a common denominator of 12. And we're going to get 4 pi minus 3 pi over 12, which is 1 pi over 12, or pi over 12. Okay, so this is cosine of pi over 12. All right, another way that we can use these formulas is by looking at or verifying identities. So the first one we have here is a cofunction identity, which we already know why that's true. We've talked about that one. But now we're going to verify it with the sum and difference rules. Okay. So let's see. We've got the sine of pi over 2 minus x. So we're going to start with that side. Okay, and we are going to do this top formula. So sine, cosine, cosine, sine. So the sine of pi over 2 times the cosine of x minus, well, let's see, the sine formula is the one where we keep the sign the same, so we're good. So sine, cosine, cosine, sine. Okay, so the cosine of pi over 2 times the sine of x. Okay, so what we're doing is we're trying to prove that this is equal to cosine of x. Okay, well, I can't figure out what the cosine of x is or the sine of x is, but I can figure out what the sine of pi over 2 is and the cosine of pi over 2. Go to your friendly unit circle. All right, the sine of pi over 2 is 1. All right, just think of the unit circle, that's 90 degrees. The cosine of pi over 2 is 0. So multiplying this by 0 is basically going to make this entire thing go away. And so we just have 1 times the cosine, which is just cosine of x. And it follows through. Okay. These are also known as reduction formulas, and they're handy in calculus when you want to do some calculations or derivatives and antiderivatives that you do in calculus, but you want to make them simpler for you. Okay, so let's try another one. We have sine of x plus pi is the negative sine of x. Okay, so same formula, sine, cosine, cosine, sine. Okay, and always using the first one first, which is x, and the second one second in each. Okay, we're trying to prove that this is equal to negative sine. Okay, well, the cosine of pi, think of the unit circle, pi is over here, it's going to be the point negative 1, 0. And so the cosine of pi is negative 1, which turns all of this into negative sine. Okay, sine of pi is 0, so this is just 0, which cancels all of this out, and so it checks out. All right, let's talk about tangent. Okay, the tangent formula, you could remember that tangent is sine over cosine, so you could just take this whole formula, put a division bar, and there you got it. There's tangent. You could do that. But there's another formula for the tangent when we're doing a sum or a difference. Okay, so the tangent of u plus or minus v is going to be the tangent of u plus or minus the tangent of v, all divided by 1, the number 1, minus plus, which means sign swap, the tangent of u times the tangent of v. Okay, so let's break this down. U's here, so it goes here and here. V's here. And our signs, if it's a plus, we're going to use a plus on the top and a minus on the bottom. If it's a minus, we're going to use a minus on the top and a plus on the bottom. Okay, so let's take a look at our example here. Write as a single trig function the tangent of 19 plus the tangent of 47 divided by 1 minus the tangent of 19 times the tangent of 47. So this is pretty much the formula. It fits it perfectly. Our u is 19 and our v is 47. And you can see that the signs are plus and minus, and so that would be with the plus. Okay, so this is going to be the tangent of 19 plus 47 degrees, or the tangent of 66 degrees. All right, almost done here. We can use these identities to do something. We can express a sinusoid as the sum of sinusoids as one sinusoid. Okay. Okay, so a sinusoid, remember, is a graph of a sine or a cosine that follows the sine or cosine wave, and it pretty much can be put into that form right there. Okay, and we also looked at another section how you can add two sinusoids, a sine and a cosine, and make it into a new sinusoid if the b value is the same. And so you could see they're both 1 right now. Okay, so to begin with, what we're going to do is we're going to rewrite a times the sine of bx plus c using the sum of the sine identity. Okay. All right, so we're going to do this using our identity with our u being bx and our v being the c. Okay, and then there's this coefficient of an a out front, which I am going to put in brackets here. So this is going to be the sine of bx plus c, and now we're going to use the formula. All right, so the a is just hanging out. So sine, cosine, cosine, sine. So sine of bx times the cosine of c plus the sine, or sorry, the cosine, sine, cosine, cosine, sine, the cosine of bx times the sine of c. Okay. So then we're going to do a little weird rearrangement here. Okay. I need you to keep in mind that a and b and c are all going to be filled in with numbers. So that makes this thing and that thing and this a all kind of constants. They're just numbers. So what I'm going to do is I'm going to distribute the a, and I'm going to kind of rearrange things a little bit so that the constants are in front. Okay? So I'm going to distribute the a. So when I distribute the a, I'm going to get an a times, and I'm going to put the constants together. So cosine of c times the sine of bx. Okay, now the next one, plus a times the sine of c times the cosine of bx. Okay, so recall that this is these are just constants right there. There's no x in them. Okay. In fact, let me highlight that in a different color because we're going to use them individually. All right. So remember that we were trying to take this function 2 sine of x plus 5 cosine of x. So if you look at it, you can hopefully see the constants. The constant here is 2. The constant here is 5. So that stuff right there is 5 times the cosine of bx. Well, that's that right there. And then this right here is 2. That's this part right here. Hopefully you can see that the b is actually 1. We know that the b is 1. We can see that it has to be. All right, but we need to find the a and the c. All right, so I'm going to take 2 and set it equal to a times the cosine of c. All right, that's this one right here. And then I'm going to do 5 is equal to a times the sine of c. It's the other one. Okay. At first you're like, how do you solve for a and c here? Well, it's a system and it's going to be a weird system. Okay, and you only need to understand what I'm doing once. You're not going to have to redo this process completely every single time because it's pretty much the exact same process. Okay. All right, so what I'm going to do is I'm going to square both equations on both sides, and then I'm going to add the equations. And my goal is to get sine squared plus cosine squared, because then that turns into 1. All right, so square, 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 square. It gives me 4 equals a squared times cosine of c squared. And then this one gives me 25 equals a squared times the sine of c squared. Okay, and then I'm going to add these equations together. So I'm just going to put one of them underneath the other. So 25 equals a squared times the sine of c squared. Okay, this gives me 29. Okay, if you have a squared times cosine squared plus a squared times sine squared, you can factor out this a squared. And we get cosine squared plus sine squared, which we know from our identities, this is equal to 1. So this whole thing is just 1. So essentially, because it's multiplying, it just goes away. Okay, so we have 29 is equal to a squared. Now we're going to take the square root, and we get that a is plus or minus the square root of 29. All right. We still need to find c. Okay, so let's talk about how we find c. We can go back up to this equation here, or either one, honestly. We can do 2 is equal to a. I'm going to start with just regular square root of 29 times the cosine of c. So we can divide both sides by the square root of 29. That cancels. And then we're going to have to do the cosine inverse of that lovely thing. So you can work out this thing in a calculator and you're going to get the angle. Now, notice that I chose the positive square root of 29. The question was asking us to express it as a 1 sinusoid, okay? So it doesn't matter. There's more than one option here, and that's okay. We will pretty much get the same. Well, it's gonna be fine. Okay, you don't have to worry about which one. So just use the positive one. That's my point. So putting it all together, we now know that this is C. We know that this is A, or the positive one is A that we're going to use, and B is 1. So we can write the whole thing, okay, using that formula up here. So A goes in front, so the square root of 29 times the sine of B, which is just 1, x, plus C. And our C is cosine inverse of 2 over the square root of 29. And that's how you could write it. All right, the end.